So let's say this is the plane or whatever, or rock, yeah?
Okay.
At the top of the thingy, yeah?
Okay.
If it's at the top, then the free body diagram would look like this. There's an FG down, okay?
Mm-hmm.
But there's also the tension force is also downwards. If the plane or the rock is at the top. If it is at the bottom, okay, like there, let's say it's at the bottom, then the tension force is up and the gravitational force is down.
Okay.
Okay, so since this is at the top, FA won't be in that direction. FA is going to be in this direction. Okay.
Okay.
FA is the applied force or the tension force. So if we use that logic, so this is the plane, we have FG, we have FA, right?
Yeah, the applied force and the gravity. Okay.
Yeah. So F net, right? So the vertical forces cancel out. We don't really care about the
Yeah.
horizontal forces. So F net is M times A, right?
Yeah.
So F, what's the F net here?
Doesn't give you the mass, does it? Well, it's just FG times F.
So
Sorry, FG times FA. Or minus subtracting. Subtract them.
they're in the same direction.
Oh, then you add them?
Yeah, you add them up. But now notice if they cancel out, right? They have the same magnitudes, yeah?
Sorry, what cancels out? Oh, like the FG
Yeah,
and FA?
yeah.
Yeah.
So you just have 2FG equals MA.
Why is it 2?
So you have FG plus FA, yeah?
Yeah.
Since they canceled out, right?
Oh, yeah.
Equal. So I'm just going to say both of them are FGs, or they're equal in magnitudes.
Okay. Okay, I see what you did. Yeah.
MA. And then we have 2 times MFG. What's the formula for FG? 2 times M times G. Yeah.
Yeah, times 9.8.
Like that. Good.
Yeah.
Now see,
Do the
they've
M's
not given
cancel each
us,
other?
yeah, exactly. They've not given us the M's for a reason. So A is simply going to be 2 times gravity, or 2 times 9.81.
Yeah. Which is like,
Yeah, which is approximately 20. It's going to be 19.62. There we go.
yeah.
Once we have the A, we plug it in here.
Okay. I see what you did, and then just time by 1,500 find the
Yeah.
square root, right?
Yes, exactly. Yes.
So because because that only happened because the vertical force is 0, right?
Yeah. So that means they're the same magnitudes.
Okay, but the plane's going up. How is the applied? I still don't understand how the applied force in the they're the same direction, I guess.
The plane is going sideways. It's going horizontally. Because if the vertical forces cancel out, right? It's going horizontally. And in a question like this, and in all these circular questions, there's an invisible force, okay? The net force, yeah?
Yeah.
The net force is always towards the center of the circle. But you don't show the net force in the free body diagram.
So it's always going to point to the radius.
Yeah, exactly, to the center of the circle. And that's the net force.
Okay.
Find the A value.
I think if we do more questions, I'll get used to it. Because I haven't done any of these questions yet.
All right, let's look at the next one. Alrighty.
Okay.
So there's an object. It's swirling around, right?
Yeah.
And it says find the maximum and the minimum tension in the string.
Okay.
So how do we go about doing this? What's the first step?
So we just draw it first?
Yeah, so if you draw the free body diagram, actually, where do you think would the thingamajig would have the maximum tension, and where would it have the minimum tension?
Would the minimum be at the radius?
So this is a circle, right?
Okay, this is a circle. Mass is 3 kg.
Yeah, so let's say it's at the bottom, right? Let's say it's at the bottom, yeah?
Well, it doesn't matter if it's the bottom or the top, it doesn't, right?
Well, one of them will be the max tension in the string, one of them will be the minimum tension in the string.
Okay.
Like if you ever like swirl something around, right? At the minimum, it's like it feels heavy, yeah? So that's Fg. So this is gonna be the maximum tension.
Okay.
And
The
when
one
it's
at the
at-
bottom is the maximum.
Yes, yes. And the one at the top is the minimum. Okay,
Okay.
like that. So that's the free body diagram. So maximum here
Okay.
and the minimum here.
So we're good. Yeah. Okay. And we're given the radius, which is 1.3, and then the constant velocity.
Yeah. So step one, what we can do is we can find the centripetal acceleration. Okay,
Yeah.
which is the net acceleration. That is equals to,
VR squared.
yeah, v squared over r, right? Or am I messing this up? Pretty sure it's
Yeah, I think it's v squared.
we can just,
Because there's one with time, and we don't use that one.
no, yeah, we don't use
have time.
pretty sure it's v squared over r, but it could be, yeah, it's v squared over r right there.
Yeah.
Okay, v squared over r. So we're
Yeah.
good.
All right.
It's not v over r squared. So we can find this. So v is 6 divided by r is 1.3. So 36 over 1.3. And that gives me 27.69.
And that's for both of them because it's constant, right?
Yes, exactly. So this is the acceleration for both of them, okay?
Okay.
Now let's look at this part, the maximum. From the free body diagram, what is the net force in terms of the vectors?
From the free body diagram. Sorry, what was the question again?
What's the net force?
Oh, it just for the one at the maximum, right? Isn't it
Yeah.
just FG minus FT?
I guess you could say FT is going up, yeah? So you could say it's FT minus FG, like that.
Yeah.
Is that good?
Yeah, I got that.
Right.
Because north is farther than south.
Yeah,
is
yeah, exactly. Okay. So now what is FT equals to? FT is equals to F net plus FG.
Yeah.
Good.
And we know that the F net is 0, right?
F net is not 0. F net is M times AC.
All right. Okay. And then
Plus, yeah,
FG.
FG is just M times G. That is equals to the force of the tension.
Wait, so when is F? Okay. F net.
F net is always M times A, okay?
Yeah.
But when you're doing a circular thing, like circular motion, this A, this A becomes AC. F net in a circular motion becomes AC, the centripetal acceleration. Okay. And the formula for AC is this.
Okay. I got that. And we already found the AC, which is 27.6.
Yeah, exactly. So now we can just plug in every value in here. So the mass is 3, AC is 27.69, plus M is 3, G is 9.81. That is equals to the force of the tension, right?
Yeah.
So therefore, the maximum force of the tension is just calculated play from there.
And with the force of the tension, it would be the same for the one on the top as well, right?
No, it won't be the same.
It won't be. Yeah.
No, it won't be. So this is upwards for the one on the bottom, yeah?
Oh, yeah, because you're adding the other one, you're adding
Yeah.
together now.
So now you got this? That's pretty
Yeah, I got them. Yeah.
Now let's do it for the top part, okay? Now again, A, we know that's 27.69, so I'm gonna erase this. Now again, tell me from the free body diagram, what is the F net at top?
In terms of FT plus FG?
They're both minus, right? They're both going down.
Oh, okay.
Like that?
Yeah.
So I'm gonna move FT here and I'm gonna move F net there, okay? To make this
it'll be
positive.
negative F net?
Yeah, so negative F net minus FG, right?
And you just do the math, which is what's it called? The M times the acceleration of AC, and minus 9.8 times the.
Yeah, exactly. And then from here, you just plug in the numbers.
Okay.
So the main part here is this free body diagram, okay? As long as you get this part right, you should be good. And again, remember, always do the grasp, okay? Always do the grasp. 3 points here. The teacher will be like, this kid is organized. He deserves some points, even if you get the question completely wrong or skip it. As long as you do this.
Yeah, isn't it just like the givens and
so given, required,
answer, and so
no, analysis.
Oh, then the solution.
solution, and then the last one is paraphrase. Therefore, the maximum tension is this, and then the minimum tension is this. So this is like the
Right.
therefore statement. Okay,
Right.
is that good?
Yeah, I understand that.
Centripetal acceleration, A equals V squared over R.
And if we have the time, just use the one with the time, right? Is
Yeah.
there 2 or 3 formulas? I thought there was 2, but apparently there's 2.
This is the one that this formula sheet has.
Oh, the frequency?
Yeah, this one also has frequency, but I've not really
I've
seen
never
a
used
question.
it. Yeah,
Yeah.
I've never seen a question used it. That's weird. Okay.
You want to keep doing some dynamics? What
Yeah,
else do you want to do? Or
just
projectile motion. We have never done a projectile motion question
have you
together.
not?
We have not done it together, no.
Okay, well, it's not like we can just do everything because they're all going to be on the tip, like the test. You know what I mean?
All right,
Like
yeah, I
from
think we have enough time
kinematics.
to do. Yeah, let's just start here. We'll just speed run this, and yeah, maybe not speed run it. And let me just go the formulas. It has everything kinematics, yeah. So Kyle is a car traveling at a constant speed of 150 kilometers down the road. Step 1, what do we need to do is convert kilometers per hour into meters per second.
Wait, is kinematics part of dynamics?
Yeah.
Is it? Because I'm just gonna double check it's on my test.
All right. Oh yeah, double check if kinematics is in dynamics.
No. The first thing is projectile motion. So can we just start from there?
Yeah, sure. So we'll skip kinematics.
Yeah, and centripetal force. We did that. The pulley problems. We did that. We didn't do ramp, right? Oh.
Ramp, yeah, ramp is inclined planes. We did everything
we
ramp
did?
yesterday, yeah.
And then friction. Would that count as friction problems?
Yeah, we did that as well. Remember this? This is the ramp, and then the friction is this FF, and FF is mu k times the normal force, or mu s times the normal force, where normal force is FG cosine y.
So basically, what's left is
Projectile.
banked curve problems and the projectile motion.
Okay.
Yeah. Okay. Let's just start with projectile motion.
Alrighty. A catapult launches a cat from ground level to a target located on the ground. The cat leaves the catapult moving at 100 kilometers per hour at an angle of 40 degrees. So this is the catapult. Okay, it's at 40 degrees. Yeah. So what do we need to do first is to convert this into meters per seconds.
Yeah. Do you just divide by 1,000?
So we need to convert the kilometers per hour into meters per second.
Yeah. Oh, you time by 1,000. Sorry.
So here, no, you don't times. You divide by 1,000.
Oh wait, so I said. Oh right.
So here's what you do. Okay, I'm going to show you the technical way of doing this. You see, you have an hour, yeah.
Yes.
So you wanna times it by hours on the numerator, yeah. And you want seconds in the denominator. So like that. Okay. Now, what's the conversion factor between hours to seconds? In 1 hour, you have 3,600 seconds.
Okay.
Okay, now see this hour cancels out with hour. So we divide by 3,600 and we times it by 1,000 because see, this is a kilometer. We need that to cancel out because we need a meters in the numerator. Yeah.
Yeah.
So in 1,000 meters, there is 1 kilometer like that. So
actually, I had a similar question on the test, and I think that's like the only question I actually got right. Like this, it's like similar question to like what we have right here, but just different scenario, I guess.
So you just need to times it by 1,000 and then divide it by 3,600, and that will give you, or just simply divide by 3.6. That's the shortcut. If you want to go from kilometers per hour to meters per second, divide by 3.6, and this is the way by showing the steps. 100 times 1,000 divided by
right, this meters per second.
Yeah. So that is going to be, so you see this is going to be the initial velocity there is going to be 27.78 meters per second.
Okay.
Okay, step 1, convert that. Step 2, you see this is a triangle. So we need to convert this into its components.
X and Y, so it will be Vx and Vy?
So this is the initial velocity. So this is going to be Vi. So you need to
V1x.
find, yeah, or Vix or V1x. Yeah, exactly. We need to find those guys. Okay. And we know, you see the X component is given by sine. Yeah.
Yeah.
Sorry, not sine, cosine, because it's the adjacent. X is the cosine, Y is the opposite. So Y is the sine.
So you can do just sine 40 times 27.78, you'll find V1y, right?
Yeah, exactly. So V1y, that's gonna be just sine 40 times that number there, 27.78. Yeah.
And then cosine for the V1x.
Yeah, correct. So times 27.78, that is gonna be 17.86. And for the bottom, you have cosine 40 times 27.78. So cosine 40 times that guy, we have a 21.28 meters per second. All right,
Okay, yeah, that's pretty straightforward.
part
So
two.
now, yeah,
Oh, sorry, part A. What is the cat's velocity halfway through the trajectory, size, and direction?
what does it mean when it says halfway? Like, I don't understand this part.
So this cat is gonna go this way, right? Like that?
Yeah, so like in the middle,
Yeah, right in the middle.
how would you show that? Like, do you do anything on the triangle or not? No, right,
No, you don't do anything. The triangle is only to find these guys.
right, yeah, the components. Okay,
So he didn't give us time or he didn't give us anything, right?
he did not, no.
All right, that's fine. So some things that you should know, okay? In a projectile motion question, we're gonna split it into its x and y components, right?
Yeah.
The
Can you tell-
acceleration in the x is always 0.
How come?
Because gravity is only up and down. Gravity is only in the y direction.
Oh, I thought it was for y. Oh, no, yeah, okay, you're right, because, yeah, makes sense. When
Okay.
it's on surface.
Yeah. And then we have the V1I and whatever, and then something else. Time is the one constant. Whatever
That's okay.
time is in the x, time will be the same thing in the y.
Okay,
So now let's see if we can use some of the formulas. We have AY, yeah. And we have V1Y, which is 17.86, right?
and isn't,
And we need one more thing. We just need one more thing and we can solve this problem. Now notice if it's on a horizontal thing, right? If the cat is being shot, like from here to here, yeah?
yes.
Yeah,
I
so
think,
what? Yeah, go ahead.
isn't it just V2 equals 0?
No, V2 won't be 0 because it says, you see part B, what's the cat's velocity at impact? V2 will eventually be 0, yeah?
Oh,
When
but we
when
can't use that
No, we
for the
can't.
formula. Okay, then never mind. Oh, because it's halfway is that way.
Yeah. Oh, actually, no, even at the final point, V2 won't be 0. He's going to impact with some speed, okay? It'll be 0
Okay.
after impact, but not before impact, and that's what they want.
Okay,
But
we can find the horizontal range, I guess, maybe.
we can find something else. The only thing we can find is this. What's the change in distance in the y direction from the start to the end?
Oh, that's just V1x. Or like, that's the horizontal distance, isn't it? Pretty sure.
No, vertical distance. What's the change in the vertical distance? Horizontal distance is called the range, which we can't find yet.
Horizontal range.
Yeah,
Mine makes
range is
no-
horizontal. Range is horizontal, okay? What is the range? This is called the horizontal distance. Well, here, step 1, what is the change in height, basically, is my question to you.
Okay,
That is 0, right?
how's it 0?
Because you shoot it from here, the cat's gonna end up at the same level.
Oh, okay, okay.
You see that? Yeah, the change in height is 0. Yeah? In the y
Yeah,
direction.
because it lands on the floor.
Yeah,
either way,
exactly.
or the ground.
So we need 3 things, okay? It doesn't matter which axis, we need 3 things to go forward with this problem. So what we can do is we can come up with the formulas, yeah? And see which one works. One of them will work.
It's just one that has V1. That's the only one we can use.
Yeah, so we want to use the one with the D, right? So
The last one we can use?
so this one we can't use because we're missing time and VF.
Oh no, sorry, third one, because that's final velocity, right?
The third one, exactly. The third one is the one that we can use.
Yeah.
Okay, so let's use the third one. So VF squared is equals to VI squared. So 17.86 squared. Yeah.
Yeah.
Plus 2 times 9.81 times the D value is what? 0. Right?
0.
Yeah, there we go. So this entire thing becomes 0. So the VF in the y direction, yeah,
Yeah,
is going to be 17.86 squared. And that is gonna be 318.97 meters per second. Okay.
And is that supposed to like answer the first question?
No, let's first find time. So this one's a little bit complicated. I don't know why this was the first question. I think this should have been the first question, because usually you want to find the time and then you can solve for everything else.
Okay.
Now, what else can we do? We have VF, right?
Yeah. We don't have VF.
Oh, we just found it. So
Oh.
using a
I
third
thought
equation.
aren't we finding a time? Didn't we just try and find the time?
We didn't have enough information to find the time, but now we can find the time using the second equation.
Oh, so you just found
Yeah,
final
I found
velocity.
VF. And now I'm going to use this equation to find what the time is, okay?
Okay.
So now VF is, again, you just do this one axis at a time. So that is 318.97, yeah?
Okay.
That is equals to VI. That is what?
Oh, wait. So just a quick question, sorry.
Yeah.
So after you do this, you just do like V1 minus VF divided by time?
Which one are you looking at?
No. Okay, never mind. I'm thinking about something else. Okay, continue.
So actually, did we do this right? VF squared equals to VI squared plus 2AD. No, see, VF squared is VI squared. So VF is actually the initial velocity. I didn't square root both sides. So VF is actually the exact same thing, yeah? Because this is 0.
Yeah.
So VF squared is VI squared. So that's going to be also 17.86 meters squared per second.
Okay.
That's good?
Okay. Yeah.
Now, what can we find using that?
The time?
So delta this, yeah, we can find time using this. Okay?
Yeah, okay.
Or can we? If delta D is 0, now this is just going to give us a time of 0. This one's not going to help us.
We can just use the one on top. The first one, I think it might be easier.
Okay, let's try that one. So, but the delta D, yeah, the delta D and the Y is 0 though. So that's just going to give us 0 equals 0.
Yeah, can we just solve for it? We can just, oh, I see. Well, oh, that won't make sense.
What else do we know? We don't know anything in the x direction, right? We just have the V1x as 21.28 meters per second.
Wait, what was the problem with the third one, sorry? Oh, it doesn't have time. Yeah, okay, it's not time at all. Never mind.
If we use this, well, maybe we need to, yeah, maybe this one will work.
You know, we can do, I think.
I think this one will work.
I mean, if the distance wasn't 0, I know how to solve it.
Yeah, exactly. But the distance in the Y is 0 though. And
Yeah,
we don't have any, we just have two things.
Because whatever the distance is, because time, the like final velocity is like sometimes 0, just cancel out the time.
Yeah.
And then you just divide the whatever the distance is by 9.8 times 0.5. But I don't know when it's 0 what to do. No.
Okay, let's keep going. I think this one's gonna work.
Okay.
Okay. So delta D, right? So that is 0 is equals to VFT. We're trying to find time, yeah? So 17.86 times time minus 1/2. And the A value is minus 9.81, yeah? Times T squared.
Okay.
Okay, I'm gonna move this thing on the other side. So what is that gonna give me? So that'll give me, right? Actually, do I even have to take that? Again, bear with me here. It's gonna be 17.86 T, yeah?
Yeah.
Plus 4.98 T squared, that is gonna be 0, right?
Okay.
So what does that mean? That means you can take out a T, yeah? Here, I'm gonna pull out a T, then you get 17.86 T plus 4.98 T equals 0. I'm trying to find time, okay?
Yeah. I'm with you.
And what's the next step here? This is a
quadratic.
So either this is gonna be 0, yeah? Either time is gonna be 0. A quadratic, how does that work? If you have x minus 3 times x plus 2 equals 0, either this bracket is 0 or this bracket is 0, yeah?
Yeah.
So either t is 0, that doesn't help us, right? T is 0, d is 0, that makes sense. So that means this must be 0.
So doesn't that mean t is 0?
Yeah, t is 0. So for one of the answers is t is 0, yeah? but that doesn't help us at all because we at
Because
t is-
we already
yeah,
know. Yeah.
we knew that at t equals 0, d is going to be 0, but so this one must be 0, and that's going to give us the time. So you have 17.86 t plus 4, sorry, there's no t here because I took the t out. 17.86 plus 4.98 t equals 0, yeah?
Mhm.
Subtract 17.86 and divide by 4.98, like that. That'll give us the time, okay?
But how you can't just, how did you subtract negative 17.86?
How do you solve an equation like this? Okay, let's take a step back.
Okay.
You have a quadratic like this, right? How do you solve it? You set one bracket equal to 0.
Yeah.
And then you set the other bracket equal to 0. See, you can add a 3 there. X equals positive 3.
Oh,
You set the other, yeah. So you do the brackets one by one.
Oh, but I don't understand how you got rid of the t. You know how it's like 17.86 t?
Oh, here?
Yeah.
No, the t wasn't there because I pulled the t out of this in this step.
Oh, okay. I thought it was there. That makes sense. Okay. That's why. Oh,
Okay,
there's
t
two
is-
t's.
Yeah, exactly. So t squared, I took the t out, one of them out. Yeah.
Okay.
So this means either t is going to be 0, but that doesn't help us at all because we know at t equals 0, d is going to be 0. So I'm going to set the second bracket equal to 0. So 17.86 divided by 4.98, right? That's going to give me a time of like 3.59 seconds.
Okay.
Okay, and there we go. That's the main thing that we need here. Cool.
Yeah, this question is kind of complicated, I'm not gonna lie.
Yeah, projectile motion is gonna be, because here they only give us two things, man. This made it extremely complicated. If they gave us more information, then we could have maybe done it an easier way.
So when I first choose write my givens, right? But
Yeah, right.
when is like I'm confused because the only thing I confused, right? Because I've done projectile motion before, is that the d was never 0. You know what I mean?
Yeah, exactly. Yeah, in this case it's 0, so that made it even more complicated. But the process is the same though. You first do this, right?
Then yeah, find velocity, second velocity, and then you just do find time.
And then remember this, ax is always 0 in the x, right? Ax is 0 and ay is always minus 9.81.
Okay, but now you know how you have to find what's the cat's velocity halfway?
Yeah, yeah. So we have the time, right? We have the time.
Yeah.
So we can half the time to find the cat's velocity. So 3.59, what's half of that?
How do you just have the time? I don't get that.
Oh, because it's a halfway through.
Yeah, I get that, but why is the time? Why?
So
do you divide the time by 2? Okay.
Yeah. So at this point, right? At this point, it's going to take him half the time to get to the halfway mark and then half more to get here.
Yeah,
so
but
if the entire thing is 3.59, then at the halfway mark, it must be half the time.
Mm-hmm. Yeah.
Good.
Don't you have to do the distance as well? Like how are you going to find the velocity? Is there like
yeah. So yeah, we're going to use one of these. So once we have t equals 3.59, yeah.
Yeah, divide by 2.
Yeah, we divide by 2. So what is that going to be? 3.59 divided by 2. 1.795, yeah?
Yeah.
795. So let's find the v here. So t is going to be 1.795, right? Same thing here. T is going to be 1.795. So what can we use to find the velocity? T is equals 1.795.
The distance, I guess.
Oh, we can use this one. We can use this one.
Do we just find the velocity by that?
Yeah. So we find the velocity in the x, we find the velocity in the y, and then we use the Pythagoras theorem.
But you don't have to divide by 2 because you know, like velocity, you just divide the time. That's it, right?
Yeah, you just divide the time, not the velocity. Okay, so we're going to be using this.
Okay.
We're going to be using this. So the VFX, okay, in the x direction is VIX, which was 21.28 plus, yeah, I'm going to do it in the x direction first, plus 0. Acceleration is 0 in the x, and the time is redundant in the x direction. So at the halfway mark, VFX is 21.28.
Okay.
Now we're going to do the same thing in the y direction. In the VFY, okay, the final in the y direction is equals to V1 in the y direction, so 17.86 plus the acceleration in the y. Now that matters, right? Because that's 9.81. Yeah. Times the time is half of that, so 795, like that.
Okay.
Good?
Oh, yeah. Good so far.
So that is going to be 17.86 plus negative 9.81 times 1.795. Negative 9.81 times 1. This is just a calculator play here, plus 17.86. So the final velocity in the y is 0.25. Okay.
Okay.
I just added them up.
So you always have to find the x and the y, right?
Yeah, correct. So therefore, the net velocity in the y direction, sorry, in the general direction, is vfx squared plus vfy squared.
Was there some formula for that, or do I have to memorize
No,
that?
this is the Pythagoras theorem.
Oh, right.
X squared plus y squared is
Yeah.
the hypotenuse, right? And then you just plug these two in. 21.28 squared plus 0.25 squared on the calculator, and that's going to be the answer to A.
Okay.
We
That
have
makes sense.
basically already answered most of the questions.
It's like a triangle. Like
Yeah.
yeah. Okay.
So what's the cat's velocity? It's this guy. Okay, it's gonna be like 21.3 or something. The answer to this in a calculator. B, what's the cat's velocity at impact? Yeah.
Okay.
See, we have the final velocity, right?
Okay.
And again, we can use this formula. We have the final velocity in the y direction. We can use this guy to find the final velocity in the x direction as well. Yeah.
For
like
final velocity, yeah. We just
in
sub
the
in
x
everything.
direction.
Yeah.
Yeah. So at impact just means when time is 3.95. So now notice this again cancels out. So the final velocity in the x direction is this. Okay.
And for y
is we already had that in the beginning, and now you do the exact same thing. You just square root them. You just square them and square root that.
Oh, it's basically the opposite triangle.
Yeah.
Basically.
So once you have the time, everything becomes easy. See, now we just did B and C. Oh, sorry, we just did A and B. C, we did the very first thing. C is the first thing that I found. How long is a cat in the air? 3.59.
The maximum height isn't that just fxy? Or sorry, f1y?
So not f, d1y.
d1y, sorry.
So what's the maximum height? So this one you have to remember something, okay?
Yeah.
At the maximum height, the velocity in the y direction, okay?
0.
Is 0, exactly, perfect. Yeah?
Yeah, forgot that.
So we have velocity in the y 0, we have the initial velocity, and we have the acceleration, right? So we can just
use the formula.
Yeah, we can just use one. If you have 3, you have everything. So we're looking for the height, we're looking for D, yeah? What do we have? We have the 2 V's. So this question, do we have time? No, we don't have the time.
With time? Oh, no.
No, at the maximum height.
Yeah.
It's going to be this one.
Okay.
Right, so VF squared in the y is 0. VI is going to be 17.86 squared, right? Plus 2 times A is minus 9.81 times D, like that. We're using this equation.
Yeah, I understand.
Okay, so how do you solve this for D?
So you just at least 17.8. You just like basically use the math first.
Yeah. So you subtract 17.86 squared on both sides. You can do this, and then you just divide by 2.9.9. This is a linear equation. This is simple. Okay?
Yeah. Useful.
Yeah. So 17.86 squared divided by 2 times 9.81. Then I get a maximum height of 16.25 meters.
Okay.
Good.
Yeah. So when it says what's the range, so you're supposed to we're supposed to solve how far she traveled, or
yes. Yeah. Horizontal distance. We're trying to. We need dx, delta dx, the change in distance in the x direction. That's the range.
The horizontal range, right?
Yes.
Okay.
And that one's pretty easy. You see, did you understand this question?
Yeah.
The maximum height just said
the
BF. Yeah. So for the range, again, it's very simple. It's the fourth equation. This guy right here.
Yeah.
So the change in distance in the x direction, that's what the range is equals to VI times delta t. So we know the initial velocity in the x was 21.28. Yeah. Times the time, we know that is 3.59. And again, the A in the x direction is 0, so you can just ignore this. So this is going to be the range, 21.28 times 3.59. And that is like 76.4 meters. And you're done.
That question was very annoying. I'm not gonna lie to you.
Yeah, I understand. Because they only gave us like one thing, like the initial velocities.
Wait, you study engineering, right?
Yeah.
Is it just a bunch of physics and math?
It's all physics and maths.
That is very disappointing.
You love it.
Because I actually want to get into engineering as well. That's what I'm trying to get
Alrighty. Yeah, it's not easy.
to. What type of engineering study?
Civil.
Oh, for real?
Yeah, why?
That's why I'm trying to get civil engineering as well.
All right, it's tough. You know, I guess it depends on how good you do in these courses, right?
Okay.
All right, you want to do another projectile? Should we do something else?
I say let's just do projectile and just go to math, I guess. We have 15 minutes and just skip the math.
All right, now let's look at this. The initial height is 30 meters, okay?
Yeah.
So we have something like this. So that this is 30 meters. Now what's happened here? The cat is launched at an angle of 55 degrees. Make a rough sketch, step 1, okay? And can be assumed to be at ground level during launch. So I guess we just ignore this. With what speed does it have to be launched to make it approximately 5 meters over the wall if the wall is 250 meters from the cannon?
Okay, so I'm trying to see if we.
Oh, the wall is
Okay.
30 meters, not this. So this is the cat. It's gonna go this way, yeah? There's a wall here, which is 30 meters tall. And this distance from the cat to the wall is 250 meters.
Okay.
And we
Okay.
need to make it 5 meters above the wall. So we actually need to go 35 meters above the wall. And this distance is 35, like that.
Okay.
So step 1, we're just gonna write down the givens, right? So what do we know? This is the delta dx. Yeah, let me just put in the formulas as well. And then we'll just play around with it. One of them will always work. As long as you have 3 things, yeah? So let me set it up. So x and y. So again, you see this is your initial velocity, vi, yeah?
Yeah.
So we don't know that value. That's what the question's asking us. But we know in the x direction, that's gonna be vi times cosine 55, right?
Vi times, yeah.
And then the y direction, it's gonna be vi times sine 55. Yeah.
Okay.
What else do we know? We know that, I guess I can just call that v1x, and then this is v1y. And we know ax is gonna be 0, and we know ay is gonna be minus 9.81.
Yeah.
What else do we know? We know that the change in distance in the x direction is 250.
250.
And we know the change in distance in the y direction is 35.
Oh yeah, how's it 35?
Because
okay,
5
yeah.
meters over the 30
Yeah.
meter wall.
Okay.
Do we know anything else?
I don't think so. We should define initial velocity first, right?
Oh, yeah, we need to find vi.
Okay.
So we don't have the final velocity. We don't have the time, right? So what can we use? Guess we can use this one, okay?
But we don't have the final velocity yet.
So in the x direction, right? In the x direction, a is always 0, so this thing always cancels out. What does this
so
mean?
it's the same. Yeah,
it's the same.
Initial equals final.
Yeah. So we know that VF is gonna be VFX is VI cos 55. Whatever we started out with in the x direction, that's gonna be the final velocity as well.
Okay.
Okay. Now, how does that help us? I guess I'm gonna plug that into this equation. Because we have delta D, right? We have to play around with the delta T's, delta D's. We don't have the time, and I don't like these because they usually give you a quadratic.
But so we just sub in like VI cosine 55 squared, something like that?
So we're gonna use this, okay, here. So delta dx, so 250, yeah?
Okay.
Equals to VF is VI cosine 55, right? Plus VI is the exact same thing, VI cosine 55, yeah?
Okay.
Divided by 2 times delta t.
VI cosine 55, okay, divided by 2. Got it.
Okay, so now this becomes 2 VI cosine 55, yeah? So that 2 is going to cancel out this 2. So you get VI times cosine 55 times t is 250.
Wait, what happened with the 2, sorry?
Because these two, I added them up, you get a 2vi cos 55
Oh,
over
yeah,
2,
yeah,
they
yeah.
canceled out, okay?
I see what you did. Okay.
So next, we can just make an equation out of this. So vi is 250 over cosine 55 times t.
Okay.
Good so far?
Yeah, yeah.
Now we're going to do the exact same thing in the y direction, and hopefully we get the t. And once we get the t, the vi is in the bag.
Okay.
So do we have the vf though for this? Hello? You
No,
hear
we
me,
don't.
right? So
Yeah.
what do we have? What can we do in this case?
Wait. Okay, now I'm a bit confused.
Yeah.
So I understand how you got 250 minus, whatever. But why do you want to use the y now?
Because see, I have two variables, two unknowns in the same equation.
Right.
So I need another equation with the same two variables to cancel them out, to cancel one of them out to get to the answer, okay? And I already used, I already used all the information I had for the x.
Oh, so don't you just use the sine 55?
Yeah, we use the sine 55. So now we're going to focus on the y. We're going to get an equation that has vi and t in it, okay?
Okay, yeah. Okay.
So what can we use? We have to use something with a d on it. So I'm going to use this one. Okay.
Oh, I think I know what's happening.
So VF squared, we don't know what that is. That's fine. So VF squared is equals to VI squared. We know what that is in terms of VI, yeah? Sine 55 squared. Let's see if this helps us. It should, I think. 2 times negative 9.81 times the delta D, which is going to be 35, like that, yeah?
Okay, so do you just do cosine? Okay, I think I know where it's going. Okay, continue.
You sure?
I think so, yeah. So first of all, we just solve for it, right? You just do the 2 times 9.8 and then times 35, right?
Yeah. So what will this be? This is going to be just VI sine 55 squared plus 2 times 9.81 times 35. So it's going to be minus 686.7. So this is VF squared. Does that help us?
I mean, we can add, so that's what I think we're supposed to do, right? Add 686.7, right?
Yeah.
Bring it to the other side and then divide. So, oh, it's not cosine? Like, is a VF or is that what we're trying to solve?
This is just VF. This is just the final velocity at that point.
My understanding has been wrong then.
Again, what we're trying to do is we're going to try and come up with an equation. Doesn't matter in the X or the Y, okay? VI, that has VI and T on it.
Okay.
VI and T on it. So I guess that's my bad because this one uses VF, which we can't use. So this was the next step actually. It's because we have D, that's good. We need VI and T, yeah, that's good too. And you see, we have everything we need. So we need to use this equation.
Wait, we need VI and T, right?
Yes, yeah, so this was the one to use. Because if you use VF, right, we don't have a VF here.
But then for the one you just said, don't we have to find 3 things now? Because okay, well it's 2 things, but now you have like 3.
Yeah, we have 3 things. So it'll work out if we use that equation. If you use the third one, because it'll work out. Okay, let me show you. Now it's easy. I think we have this figured out. Delta D is 35, yeah?
Okay.
VIT, what's VI? VI is VI times sine 55 times T, okay?
Yeah, okay.
Plus 1 over 2 times negative 9.81 times T squared.
Okay, yeah, okay.
Good so far?
I'm good so far, yes.
Alrighty, now look at this. We're gonna make a quick substitution. You see there's a VI here? We're gonna replace that VI with this. 250 over cos 55 times T, okay?
Okay.
So 35 equals VI. What's VI? VI is 250 over cosine 55 times T, yeah? And then there's another extra t right there. Actually, there's a sign there as well. So we have that. That's just VI. And then we have sine 55 times t.
Okay. Plus 1/2.
Yeah, plus what is this? Minus, well, it's gonna become minus 4.9 4.9 t squared, like that.
Okay.
Good.
Good so far, yes.
All right, now look at this. This t cancels out with this t.
Oh, because yeah, you're multiplying. Okay.
Yeah. So I'm gonna plug 250 sine 55 divided by cos 55 on the calculator. 250 times sine 55 divided by cos 55, and that gives me 357.03. Okay.
Equals 35. Yeah.
Minus 4.9 t squared. Good.
Oh, and then you subtract it.
Now exactly. Now we subtract it. So you have a 35 minus 359, whatever, 357. So 35 minus 357.03 is equals to minus 4.9 t squared. Okay.
Okay.
So 35 minus this gives me minus 322. Minus 322.03 is equals to minus 4.9 t squared. Yeah.
Yeah.
Divide both sides by negative 4.9 and then square root it. There we go. I got t as 8.10 seconds. Once you have t, you can find the initial velocity, because initial velocity is 250 divided by cos 55, and then the t was 8.10.
Okay.
And there we go. And the answer is 53.81 meters per second.
Okay.
Okay, all the projectile questions are very similar. If you set it up,
Yeah.
you need three things, at least
Yeah,
two
yeah.
things. Time, if you can find time or time in terms of something else, you should do that for the first step.
Okay. Yeah, that was I don't know. I think that's probably gonna be like the hardest question on the test. Projection motion. Takes the longest as well. Okay. So okay. Yeah. Let's see that.
You got the idea though?
Yeah. So I'm gonna start making the chart. You know how you do it like that?
Yeah.
That's a very good idea.
And then you just need three things. All right, check the formulas, which one has three, yeah? And one of them will always have three. As long as you've written all the information out, one of them will always work.
Okay.
And this thing will never be given in a question. This is just intuition. AX is always 0. AY is always minus 9.81.
Yeah. Sounds good.
Alrighty, what's next for us? You gonna keep doing this?
Can we just do like one more question, just a simple question? No, very long one, and then move on to math.
Yeah.
Yeah, like this question. This question seems nice. I like it.
Yeah. So remember, in this question, you have two different boxes. Yeah. You need to do them one at a time. Okay.
Yeah.
This one we can speed on this. Yeah, we basically did this yesterday. So I'm gonna focus on the top one first, right? To draw the free body diagram of the top one. So what's this guy's mass? Box A is 2.5 kilograms.
Yeah.
It's gonna have an FG going straight downwards, right?
Yeah.
This angle is 25.4, and then Fn is gonna go that way. So step one, we're gonna convert this FG into FGY, yeah?
Mm-hmm.
And then
FGX.
again, yeah, exactly, and then the FGX. This angle is up there, okay, like that. And what else is acting on this? So we know FGY is gonna cancel out with that one, and we have this, and we have a frictional force. Yeah, coefficient. Yeah. So we have a frictional force, but we also have one more force here.
The FT?
Yeah, perfect. There we go. FT, right? Yeah.
It's the same for both A and B, correct?
B is going to be different. B is going to look like this. You have an FG down, and then you have an FT up. Oh yeah, FT is the same.
The same.
Yeah, exactly. FT is the same magnitude for both of them. So this is very similar to the question that we just did, actually. From the first box, we're not going to get the answer. We'll get an equation. And then we have
two equations and we put them together.
Yes, perfect. Well, let's do this. Look at the free body diagram. What's the net force?
M times A.
Yeah. From the free body diagram. Yeah.
Okay, so it'll be F. Wouldn't it be just FGX?
Yeah, but we have to subtract two different things. Yeah, minus
FGX minus the frictional force.
Yes, and then one more.
And then plus FT.
No, minus FT. because this is going this way,
Oh
right?
yeah, because this. Yeah, okay,
Yeah.
I meant like you add the frictional
Yeah,
force and the FG
yeah.
is the same way. Yeah. Okay.
Okay, and then the F net is MA, right? And FGX is, again, look at this. The X component is sine, okay?
Yeah. So sine 25 times 9.8
Yeah,
times
exactly.
2.5.
Yeah, so times this. And the frictional force is mu K times the normal force. Yeah, always frictional force is mu K times the normal force. And the normal force is always FG cosine Y. Or sorry, FGY cosine, that's what I meant. FGY, okay? You see this one?
Yeah.
And that is FG mu
because they cancel
K,
each other.
yeah, FG times cosine of theta. Okay?
Yeah.
The frictional force is mu K times FG, which is mg,
Mhm.
times cosine of the angle, 25.4. And then finally, FT, we don't know what that is. It's going to stay as FT,
Times F2.
minus FT.
All right.
Okay, now I'm just going to plug in all the values for this. M is 2.5a. Sine 25 times mg is going to be sine 25 times 9.81 times 2.5. So that's going to be 10.36 minus mu k is 0.54 times mg times cosine of 25.4. That's going to give me 11.96 minus ft, like that.
Okay.
Okay, so now let's get this equation. I'm going to solve for ft, it's easier. So 10.36 minus this is going to give me minus 1.6 minus ft equals 2.5a. Okay.
Plus 1.6.
Yeah, and then you can just multiply by -1 to get solve for ft.
So yeah, so it becomes negative.
Yeah, they both become negative. Perfect. So you have this, and then you multiply that by -1. So we get our first equation. Ft is minus 2.5a minus 1.6. Okay.
Oh yeah. Okay. Okay. Yeah.
Good.
Mhm.
So now we're gonna do the same thing for the other box, and we should be able to jumble them up together.
Yeah. We just need to find the acceleration, right?
Yeah. So here from the free body diagram, what's the F net?
It's is it 0?
Ft minus, it's not 0, it's moving. Ft minus Fg, right? Free body diagram is this.
Yeah.
Ft is just Ft, we don't know what that is, and Fg is the second box is 5.
9.8.
Yeah, exactly. 5.5 times 9.81, like that. Yeah.
Yeah, and we know the mass.
Oh, so now I'm just
We
gonna
just divide
substitute
it.
that with this. Yeah. We don't need to divide it. See, Ft is here.
Well, to find acceleration, eventually you would.
Oh,
no, never mind. Okay, we'll just sub it in.
Yeah, we just sub it in. In this case, you don't need to divide. So Ft is minus 2.5a minus 1.6. Yeah.
Yeah.
And
So-
minus 5.5 times 9.8, whatever that is. And then the next step, I'm just going to add 2.5 on both sides. So 5.5a plus 2.5a is 8a. Okay.
Yeah. Minus.
Yeah. So minus 1.6 times 5.5 times 9.81, like that.
Yeah, and then just divide by 8, whatever you get.
Yeah, yeah, exactly. You can see 86, and then you divide both sides by a.
And then when you find a, you sub it in for the ft, right?
Yes,
right
exactly. You sub right here, sub a in there, and you'll get ft. And all these questions are the same.
Yeah, I like these questions. I like them.
Alrighty, that's good. Yeah.
Okay, sounds good. I think we can move into math now.
Alrighty, what are you doing in math? What is the test on?
It's kind of remember like the absolute values
Yeah.
we did, and okay, that's part of it. You know, and behavior and all that stuff.
Yeah.
It's okay. Actually, I can send you a quiz. I've already done the quiz, just like similar questions like that. You know what I mean? Well, just function their properties. I don't know.
So it's chapter 1, yeah?
Yeah, it's chapter 1.
We can do the quiz from the book, like the practice test from the book.
Yeah, we can do that because he gave us 2 quizzes and I already finished both for himself.
How'd you find them?
Honestly, pretty easy. I think I just didn't know how to solve 2 questions, right? Other than that, well, I know now, but other than that, I'm confident. Yeah, it's just like grade 11 reviews. There's no other than the end behavior and like the absolute value and stuff. There's nothing new.
So it says consider the graph here is a relation a function. This one, is this a function?
Okay. Is there a relation? Explain. See the domain range. So am I supposed to say parent function?
No, is this a function or not?
Well, it is a function.
Yeah, so what's gonna be its domain and its range?
Oh, x can be anything and y can be anything.
No,
Well, x can be anything.
Yeah, what about y?
Y. It's greater than -5. No, wait, no.
Nope.
Well, I know the domain, the range. It's less than? Wait, what? I'm confused. I don't, domain range is stupid. I hate it. Okay, let's go. Okay. Oh.
Okay, the range is, look at the minimum value, right? Well, what's the minimum value gonna be? 0.
Oh, yeah, I don't have to write the 0 though. That's why I just said x is anything and y anything. You said you can just write one of them. Well, you said just write the anything.
You won't get away with just writing what you are. You have to write this as well, okay? Because y cannot be, y is always gonna be 0 or more than 0. It's never gonna be below 0. So there's a restriction on the y. Okay?
Okay. Yeah.
What about something like this? Let's say this point is 6 on the y. What's the range of this?
It's less than?
Yeah, it's less than 6. Okay, less than or equal to 6.
Okay.
Okay, it's pretty simple, right? It's quadratic. It's not that bad.
Okay.
Let's do the next one. Given the following information about a function. So now they've given us a bunch of details. What is a possible parent function? So the domain is XCR, right? So what we can do is we can kind of see which functions have a domain of XCR. You have y equals x, yeah?
Yeah.
The linear function y equals x squared, y equals the absolute value of x, y equals 2 to the power of x, y equals sine x. All these guys have a domain of XCR, okay?
Yep.
Next part says the range is gonna be greater than and equals to -2. So if you look at them, you see the first one, linear function? The
Yeah.
range is YER, there's no restrictions. So this is not our function. Okay?
Sorry, come again. So
Yeah,
y
so
here.
the range for the linear function, yeah, it satisfies the first condition, but it fails the second condition because the range is YER for a linear function. Y can be anything. There's no
Oh yeah,
restrictions.
it can be okay,
Yeah,
-2.
So that does not satisfy the first condition. Sorry, the second condition, this is out. Both of these satisfies the second condition. Okay. So they're still in, and then finally both of these also fail the second condition.
Yeah, absolute value is just a v, right?
Yeah, exactly. It's just the same thing as a quadratic. So it says decreasing on the interval -infinity to 0. Okay.
Mhm.
What does that mean? That means on the x-axis, the function is falling all the way until x is 0. Decreasing means something like this.
Oh, and then yeah, the y just
Yeah,
0.
and then on the other side, it's increasing. So there we go. So it's probably a quadratic, and you can also be a v. They both satisfy all the conditions here.
The absolute value. Yeah.
Yeah.
So that
It's
doesn't
just
help
gone
us.
2 units down. Yeah, it's just gone 2 units down. So it's gonna be like that at -2. And if it's a quadratic, it's gonna be like this at -2 because it's gone 2 units down.
Okay.
So what is a possible parent function? It's either a quadratic or it's an absolute value function.
Draw a possible graph of the function.
Right.
Didn't we just draw that?
Yeah, we just did it. Describe the transformations. So how did we go from this parent function, right, to this?
You just went -2, just went down, I guess. Like the y became -2. Wow.
So the transformation is you went 2 units down, or a vertical translation of 2 units down.
Just yeah, I would just say down by 2.
Yeah, that's cool too. All right.
Okay. But it doesn't. We didn't find an answer, right? Just there's 2 options, I guess, to answer it.
Oh yeah, so it's either gonna be the quadratic x squared or it's gonna be the absolute value function.
Yeah, I feel like that's the main thing I'm struggling with is the parent functions and how they look like. I need to kind of memorize that.
Now, let's do that part. Let's do that part. And we're also gonna do end behaviors and everything. All right, let's do this. Y equals to x, yeah?
Mm-hmm.
Looks like this, right?
Linear.
Yeah, so it's increasing. We're going to do increasing intervals, decreasing intervals, and then the end behaviors. Okay,
Okay.
look at this function. Where's this increasing?
There's no increase. Well, it just increases once.
No, it's increasing everywhere. When increasing just means when is the function going up?
Oh, it's just all the time.
Yeah, so it's just from negative infinity to positive infinity, it's increasing. It's never decreasing. So decreasing does not exist.
Oh, that's yeah. And
Now,
then
end behaviors. So when it comes to end behaviors, yeah,
Mhm.
you're always gonna write this thing as x goes to negative infinity, and then as x goes to positive infinity.
Yeah, and then you just talk about you see what happens to y, right?
Yeah, exactly. So when x is going to negative infinity, where's y going?
It goes negative as well.
Yeah, exactly.
Okay.
What about on the other side? As x goes to positive infinity, where's y?
Positive as well.
Yeah, there we go. So that's the linear one and done. Yeah, easy.
Yeah.
This is quadratic. Quadratic and absolute value function is literally the same thing. Well, it's not literally the same thing, but they have the same
Very
properties.
similar.
Yeah.
Yeah. So it increases.
When is it increasing? When does it decrease? Oh, we can also talk about we can also clearly talk about domain and range.
Okay. No, let's do that first, I guess.
Yeah, for the first one, it's just x here, x here. Yeah. What about the second one, quadratic? And again, quadratic and this, they have the same domain and range.
Yeah, so x can be anything.
Yes.
And then as we said, y is greater than or equals to 0, or x can be anything. Or sorry, y can be anything.
Yeah. So you'd say YER, yeah, and then semicolon or a line. 0. Yeah, y is greater than or equal to 0 for both of them. Okay. Very similar. Properties are the same. Where is this function increasing?
So it's from 0 to infinity.
Yeah, good. Where is it decreasing?
It doesn't decrease.
It does decrease.
Oh, is it just at the 0? Is that what we're trying to like?
It's the decrease on the left.
Okay, so just from 0 to negative infinity?
Oh, yeah. So negative infinity to 0. You want to put the lower number on the left.
Okay, yeah, okay. It makes sense. Yeah, I completely forgot.
Yeah, so it's the same thing for this one as well, yeah?
Yeah.
And the end behaviors. So when x is going to negative infinity, where's y going?
It's going to negative as well. No, it's going up positive.
Oh, yeah, positive, right? And what about when x is going to positive infinity? Where's y going?
Yeah, it's going positive as well.
Yeah, there we go. So this is the exact same for both of them.
Okay, sounds good.
Let's move on to the next one, the square root function. Y equals to square root of x. Looks like this, the parent function.
Yeah.
What is the domain? What is the range?
The domain, x can be anything?
Nope. X cannot be anything.
X can't be.
X cannot be negative, right? Because you can't take a square root of a negative number.
So it's x is greater than 0?
Yes. XER, x is greater than or equal to 0.
And then y is greater than 0?
Yes. Where is it increasing?
It's just increasing from 0.
Yeah, it's increasing from 0 to infinity, it's increasing.
Yeah.
It's not decreasing anywhere, okay?
Yeah, NA.
Yeah, exactly. Now, end behaviors. So this does not go to negative infinity, so we don't really care about that in that direction, okay?
So just the positive, just positive x.
Yeah, when x is going to positive infinity, y is going to positive infinity.
Okay, yes.
Good?
Yeah.
The next one is the exponential function, 2 to the power of x.
I forgot how this one looks like.
It's like this.
Oh, it's asymptote, the one with 0.
Yeah.
I remember doing this when we reviewed. Yeah, okay.
What is the domain?
The domain, x can be anything.
Yes. So x here, what's the range?
Range is y can be.
Y can't be anything though. Y won't be anything. There's a restriction.
Well, yeah, that's I know it can be anything, and there's also restriction. Isn't it just a 0 as well? So, it's equals to y equals to.
Like that?
Yes, I believe, but I know it's wrong. That's what I thought.
So here, y is going to be strictly greater than 0. It's not going to be 0. It'll never get to 0.
Oh, right, because it never hits the 0. Yeah. So just y. Okay.
It's just strictly greater than. Okay, notice the difference. Here it was greater than equal to 0, but here it's strictly greater than 0.
Yeah. Okay.
Where is it increasing?
It increases from I don't have the numbers though.
Everywhere. It's look at the graph. It's going up the whole time, right? So negative infinity to positive infinity. It's increasing and it's not decreasing anywhere.
Isn't it decreasing to the left?
No, it's still increasing to the left like that. It's increasing all the way through.
Wait. I understand to the right, to the left. How's that? Oh, because it says the same level. It doesn't actually go
Yeah, it
down.
looks like this. Looks like this on the left. If you zoom in on it, right?
Yeah, okay, I see.
So it's not decreasing anywhere. Okay. The y values are always going up. So what does increasing mean? Increasing means as x goes up, y goes up.
Yeah.
Decreasing means as x goes up, y goes down, right? If you look at this half of the quadratic, as x is going up, the y values are going down.
Okay, makes sense.
But here, as x is going up, the y is going up the whole time. What about end behaviors? When x is going to negative infinity, where's y headed?
To 0?
Yeah. What about when x is going to positive infinity?
Y is going up.
Yeah, all the way to positive infinity, yeah?
Yeah.
Alrighty, so that's that. There's a couple more. You have the reciprocal function, y equals to 1 over x. Looks wonky, looks like this.
Oh, isn't that's the one that's a restriction, right? Let's say it's 2x or whatever.
Yeah.
X can't be 0 or something like that.
Yes, exactly. So the domain is XCR, x can't be 0. Same thing with the range.
And Y
YR,
can't be 0.
yes. Where is it increasing?
It's from, and it's not, I don't see it increasing. It increases once. So I guess
It does not increase anywhere.
Yeah, that's why I'm confused.
What about decreasing?
It doesn't decrease either.
No, it's decreasing everywhere.
Oh, so you just say from like positive infinity?
Oh, you say
Negative?
like this, negative infinity to 0. Okay, union, and then you go from, because it can't be 0, right? It's XCR, but except for 0. Or you can say it like this, it's decreasing at XCR, but x can't be 0.
Isn't there like only 2 that can increase? For sure.
Increase, this one increases, the square root, and this one also increases. It's always increasing. Both of these are always increasing.
Yeah, okay.
Linear
I
as
see.
well, linear as well.
Yeah, most of them increase.
Yeah. This one is always decreasing, okay?
And the last one is sine, right?
Yeah, so what about the increase? Sorry, the
Oh,
end
the end behavior. Yeah, sorry. So when x goes up, y goes up?
As x goes to infinity, y goes to infinity? No. Let's focus on the left half. Look at this.
Okay, so it just goes to 0 then.
Yeah, exactly. What about on the right half?
It goes to 0 as well.
Yeah, there we go. That's it, yeah.
Oh, I got confused because you see how there's an arrow pointing up? Yeah.
Yeah. No, you don't look at that. You look at the extreme ones, right? You look at the extreme ones. That's just what it looks like. And then finally we have the trig function, y equals sine x.
It's a zigzag.
Yeah, it looks like this. Cosine x is very similar as well. Y equals cosine x looks instead of it going through the origin,
just different degrees, right?
Yeah. Okay, so but for this one, you don't care about the end behaviors because it's undefined.
Just the range and domain.
Right? Yeah, just the domain and the range. Where's the domain?
The domain x can be anything.
Yeah. What about the range?
Oh, okay. So it's equals to or greater than -1.
Up to 1. Yeah, greater than -1, but up to 1. Yeah. So you write like this.
Oh, like the 2 ones. Yeah.
So -1 less than y less than +1, like that.
Okay.
Good.
That was a good review, actually. I feel more confident now. That's like literally, I don't think you understand, right? I can do any complicated question, but when it comes to these stuff, which you're supposed to get easy points from, right? I just don't understand. I don't know why.
All right, let's go back to the question. So algebraically, that this function is an even function.
Well, isn't there a formula for this?
There is.
Fx equals -x?
Yeah, so f of -x is gonna be f of x for an even function.
Yeah, and then for the odd, they're both negative, right?
So there's a negative inside, but it comes out. So like this is an odd function.
Yeah. So there's 2 minuses.
All right, so step 1 is just to plug f of -x. So what would f of -x be?
It'll be fx.
So f of -x.
It'll be equals whatever. Yeah. Absolute value in 3x. Okay, yeah, never mind.
F of -x, yeah, plus what?
-x squared.
Yeah, exactly. So now this, if you look at this, -x squared is going to be positive x squared, yeah?
So it becomes positive 3x?
Oh yeah, this also becomes a positive 3x because there's an absolute function there, like that.
Okay. So it's the right one because it's the same one as the original one.
Yeah, so
it
this is
is
the
even.
exact, yeah, exactly. There we go. Easy as that.
And if it's none of them, it's neither, correct?
Correct, yes.
Okay. I understand. Actually, I didn't know that until yesterday. I kind of reviewed it. I'm like, oh.
That's good that you have been reviewing it.
I thought because when we did in class, right, it was kind of a chart and the teacher kind of just told us, right? So I'm like, am I supposed to memorize this? Or like, how does this work? Okay.
Okay, describe the transformations to get to this from that.
So it reflects on the y-axis.
But yeah,
And then it just goes down by 3.
no, not quite. So you have to look at it whether this +3 is inside the function itself, right? It's a squared function.
Wait. Isn't whatever in the bracket the opposite? That's what I thought.
Yeah, so it's not going down, it's going left.
Oh, right. So they're going down would be the -5.
Yeah. So this is the vertex is at -3 and -5. Okay, 1, 2, 3, 4, 5, and it's opening downwards. Yeah, like that. There we go.
So it goes down by -5 and then goes left by -3 and then reflects on the y-axis.
No, the order matters. The order matters. You have to do
Yeah.
this. Yeah.
You do whatever's first.
Yeah, you go this way. Okay, left to right.
Mhm.
So it says find the transformations that gave us this.
Oh, okay. That's my first time doing a question like that. Okay.
So we know that it comes from this. Okay.
So it goes right 2, I guess.
No, it doesn't go right. It goes up 1.
It goes up 1.
Yeah.
But then, because that's why I'm confused. You know how there's like goes right and left? Like which one? What are we doing?
If it goes right, it would have looked like that. Okay.
Mm-hmm. Okay.
But this one, right? The parent
It's in the
function
middle.
it goes through the origin, yeah?
Yeah, that's absolute value, guys.
Yeah, so this must have definitely gone up.
So
This is the parent function, looks like that. So it goes through 0, 0, it goes through 1, 1, yeah?
Okay.
And what else does it go through? It goes through 2, 2. Same thing, it goes through -1, 1, it goes through -2, +2. So this is the parent function. Yeah?
Yeah, and this is the original parent function. This is a transformed.
Yeah, the blue one is a transform. So we know for...
Oh, it goes right 1. Oh, it goes up 1. That's what we know for sure.
Yeah, it goes up 1. Or it could have been stretched. No, it's not stretched. It goes up 1 for sure. Yeah. Now, how did it get stretched by? Looks like there's some sort of a stretch. Yeah.
Okay.
So
Well,
how do we find that? So it's gonna be in this form. Okay. It's gonna
be stretched by 2.
So like that. Does that work?
I don't think so. No.
No, x is 1. That should have been 3, right? It's
can
just
can it be x plus 1 absolute value? No. Okay, never mind. Just forget what I said. Let's just erase it. Okay, cool. So what we're trying to find is the stretch, right?
Yeah, exactly. We're trying to find a stretch if there is one.
Well,
I drew this right? Yeah, I drew this right. So
it's either I don't understand. Yeah, I thought it would be stretched by 1 or 2. Okay.
I think it's this.
It was 2x.
Yeah, let's try. Let's plug in some points and see if we get that. So when x is
1, a y is 0.
When x is 1, yeah. What do we get for the y value?
Y is 1.
Oh no, it's not 2. 2 is not gonna work because if x was 1 here, yeah.
It'll be just 2.
It'll be 3. Y will be 3, right? Not 1.5. Yeah.
Yeah, it doesn't make sense.
It's 1 over 2. It's 1 over 2. It's 1 over 2 like that. Now see that one works.
Oh, because it's stretched, so the opposite would be 1 over 2.
Exactly. Yeah. See, 1 is 1.5, and that's the point we have here. Yeah. And look at this. 2 is 2, and now see it works out. So it's 1 over 2x plus 1.
Okay, I see. Yeah. That makes
Okay,
sense.
okay, step one, we knew for sure it did not go left or right because of this, right? It went
Mhm.
straight up. So we know this part for sure, yeah?
Okay.
And then for this part, so you have to kind of think about it for a second. If it's a vertical stretch, okay, it shrinks.
Yeah. Vertical stretch, it shrinks, and
Yeah.
when it's compressed, it,
Yeah, it's compressed either vertically or horizontally, yeah? Or sorry, it's either vertically compressed or horizontally stretched.
wait, sorry. So when it's compressed, it goes, it like,
It becomes fatter,
yeah,
like it
fatter.
is right now.
Yes, that's how you
So
fat.
we could have also done, I think that would work, and I think also this would work. Would it? No, that won't work. So it must
I
have
don't
been
think
this,
so.
yeah. So
Yeah,
it's
yeah.
a horizontal compression. Or sorry, horizontal stretch.
So we just say horizontal stretch
By
by
two.
two,
Yeah.
and then up one.
Yes.
Okay. So it gets more complicated though. You can like have.
Yeah, sure. It always gets more complicated, right?
Oh, come on.
Okay, here we go.
3, 5 is the point on the graph. Okay, corresponding. Oh, don't you just find the mapping rule and you just plug
Yeah,
it in?
you do. Exactly. That's good. You find the mapping rule.
Yes. So for the first one, it'll be negative x plus minus 1. Or does it just become positive x? I've never seen negative
So
x.
you need to pull out what's x being multiplied by. It's
Oh, you
being
just pull it
multiplied.
up. So it'll be negative 3. Oh, you pulled it out. I see what you did.
Yeah, whatever x is being multiplied by, you want to pull it out. Okay. What's
And
left in
x
the
minus
bracket?
1.
Yeah, good. X minus 1. There we go. So what does this mean? This means this is a. It always goes AKDC. Okay.
Yeah.
D is 1. It's not negative because inside it's opposite. Okay. So x minus
Yeah,
1
because when you
makes.
time it by the negative, that's
Yeah.
fine.
And the point mapping rule says any point xy that they give you becomes what?
The opposite.
What's
Well,
the
not
point
the
mapping?
opposite. Sorry.
What's the point mapping rule?
I mean, what's the point of nothing?
It's this, okay? Any point xy becomes.
Oh yeah, it's 1 over k.
Yeah, it's x over k. We're not quite done there. X over k plus d, okay?
dy.
Ay plus c, like that. And now see, we have every value. We just plug into
Oh, yeah, I see.
3, 5 becomes 3 over negative 1 plus 1, comma 3 times 5 plus 2.
Wait a second. Why did you put the 3 for the x?
Because 3, 5.
Oh, okay. I thought because you know how it's like 3y.
Yeah.
Plus
No,
2.
this 3 has nothing to do with that 3.
Okay, yeah.
Because
okay,
the x value is 3, okay?
I didn't even look at the point. You just sub it in and you find a corresponding
Yeah, exactly.
point.
So this becomes minus 3 plus 1 minus 2, 17, and that's the answer.
Yeah, and then for the b, you just find the inverse, right?
Yeah, what will be the inverse?
Wait, do we find the inverse for a, or that has nothing to do with it?
No, A is redundant. A is going to
Okay.
be different than B.
Wait, don't you just like swap them?
Yeah, you literally just swap them. What is it going to become?
Like 5, 3?
Yeah, and you're one and done.
Oh, okay. I see. Can we do some absolute value after this?
You can do it right now. I mean, let's finish this test because it kind of covers everything.
Okay.
We have time, right? We have like over 30 minutes. We should be.
Oh yeah. Wait,
Find
let's
the
do
inverse
absolute
to
value.
this function.
Okay. So what I do is I just sub in x and y, swap them.
Okay.
So it becomes x equals negative 2, y plus 1.
All right, good. And what's the first step?
So it becomes negative 2y plus minus 2.
Yeah.
And then you subtract 2.
You add 2.
Sorry, add 2. Yeah. Well, you get rid of the subtractor and then you just divide by negative 2.
And then you want to say, in the final step, you want to say that this y, we know that's f inverse of x, okay? Because they gave us f of x, yeah?
There's another way to solve it, but I just like, remember like there's like this chart kind of thing with the arrows?
Yeah.
I never like that. Just
Okay, ignore it. Yeah, let me
Yeah.
just give it to you anyways. So this method is bulletproof. So here, what's happened to x? So you're adding 1, yeah?
Add x, yeah.
You're adding 1 and then you're multiplying by negative 2. So the inverse flips, okay? The order flips, the signs also flip. So this
Right.
happened second. It was being multiplied by negative 2. So you want to divide by negative 2 and then you want to subtract 1. So x over negative 2 minus 1.
Yeah, never like that. It's just, I don't know. Okay. I don't think we actually did any of these questions.
Piecewise, no?
Sorry.
These called piecewise functions. Oh, what are you talking about? The ones that we just did?
No, the one number 9.
Okay, this is a piecewise function. It's part of chapter 1.
I've heard the name piecewise before. We haven't actually done it. Maybe we're coming in next week. It wouldn't hurt.
It's chapter 1 though. You sure?
Yeah. We haven't covered it. We might cover it next week, I'm assuming. But let's just do it. Let's just do it. Why not?
Yeah, it's not that bad. It's not that bad.
I've heard the term piecewise though. I know it's in chapter 1. Like I've heard it from
exactly,
a friend in different class.
Alrighty, let's do this. So, okay, piecewise. Okay, this is going to be the rubric. There's going to be some conditions. Actually, before we do this question here, let me explain you how this works, okay?
Okay.
So it's going to look something like this. F of x, piecewise means, depending on what the x value is, one function is valid, okay?
Oh, it can be more than one thing.
Yeah, exactly.
Oh, okay. I remember doing it, but it wasn't actually a word problem. I remember doing it in yesterday's quiz, actually.
Yeah. So I'm sure you've done this. So let's say it's something like this, okay?
I actually forgot what I did, but it was pretty easy.
Okay. It's not bad. It can get a little bit tricky when it's a word problem, but here, let me show you. So
you
this function, no, you want to graph this. So when x is equals to or less than 0, this function is valid, okay?
Okay.
X, so that's the linear graph, right? Y equals to x looks like that, but that is only valid up until this point. Okay?
Okay.
Because that's the only, up until that point it's valid. So I'm going to graph this. When x is 0, y is going to be 0 for the top function, yeah? When x is -1, y is going to be -1. So that function is valid right there. And this is the top half of the equation, okay? And you see this is equals to 0. So that means at that point, there's going to be, it's going to be a closed circle. There's ideas of open and closed circle in piecewise functions.
Right. And if it's open, it's not equals, right?
Yeah, exactly. So let's make this
I
x
remember something like that last year. Yeah.
Now let's do the same thing for the bottom function. When x is 0, again, you don't care if it's equal to 0, but when x is 0, what's the y value for the bottom function?
X squared plus 1.
Yeah. So if x is 0, what's the y value?
Oh, 1.
1, right? But see, it's exclusive. It's not equals to 0. So at 1, you have an open circle. Yeah. And now we have a quadratic equation, yeah? And when x is 1, you have y value of 2, something like this, and then you just join the dots, and there you go. This is a piecewise function. The bottom part represents the top equation, okay? And the right part represents the bottom equation.
So, sorry. So, okay, yeah, I got that. I understand. Actually, here, let me just pull up the question before we just do that, because I think it was simpler. Oh yeah, it says given determine. Oh yeah, so it gives you the x, and I think hey, actually, I don't know if I did it correctly. I'll send you the quiz as well. Oh, it's not downloaded. Open new window. Here, yeah, I send it to you.
On the email?
Yeah.
So wait, you're taking math, chemistry, and physics in the same semester?
Unfortunately, yes.
How did that come to be? That seems pretty tough.
Yeah. I went to my guidance and like what's happening here, right? Like,
yeah.
What's the meaning of this? And because I want to get into civil engineering, right? So I can't like stop in one course, right? Like I'm fine with chemistry, math. I actually like enjoy doing. Physics is kind of a problem, I'm not gonna lie to you, but it's okay. But like having math and physics, like sometimes I don't get to do my math homework or my physics homework because I'm just like so focused on one subject. You know what I mean?
Yeah. You want to do this one, question 10?
It's yeah, sure. Let's do that first because I think it's easier.
This than the one we're button. All right, this looks pretty tough. Maybe not.
Wait, number 10?
Yeah.
Okay, then I might have solved it wrong. Okay, let's just do it. Yes, that'd be good. Yeah.
It's probably easy because it's not asking us to graph it, right? Yeah.
Yeah. I'm sure when you were in high school, you didn't have you had a balanced schedule, right?
No, I didn't. It was all over the place.
Oh, you did? What school did you go to?
I did an IB program.
Oh, you did? Okay, okay, yeah.
It was a mess, man.
It's okay.
Yeah, I've been scarred for life. Anyways, F7, right? So which equation is valid when the x value is 7? Only one of them is valid.
Is it the second one?
It's the second one? No, it's not. See, it's not inclusive of
Oh,
7.
no. Third one.
So that has to be the third one. So you just go 4 times 3. Actually, we'll also graph this. How about that?
Sure.
Let's spice things up a little bit. So we do 2 times 7, even though it's not asking you, right? But they could. So you have 4 times 3 minus 14 minus 8. So that's 4 times positive 11 minus 8. 44 minus 8 is 36. And that's the answer to the first one. Okay?
You just subbed in 7 for x and you stop.
Yeah, in the third equation. Yeah, in the third equation.
So why is the third? Because it's equal, right?
Yeah, exactly. F of 7 means where it's equal.
Oh, because the other one says x is greater than x is 7. Okay, I got it.
Okay, B, the value of x at which the function is not continuous. Alrighty, so now there's 2 points of interest here, okay? Look at the x values. We have 7, yeah?
Okay.
And then we have 1. And then we also have an asymptote for this guy. Actually, it's valid. Yeah, it is valid. When x is -3, the top one is valid, yeah?
Okay, I'm kind of confused what the question's asking. Can you just go back?
Yeah. Continuous means you know, where there's a break, you see 7 and 7 here.
Yeah.
So the second function exists up until 7 or slightly below 7, and this one takes place. Yeah. Continuous means like there's no gap. You know, whatever the y value for the second function is, the third function picks up right there. So if the y value is at 7 for both of these are equal, then it's continuous at 7. Okay.
Then wouldn't it be just the one Oh, okay, I see. So they have a lot of like terms like that.
Yeah. So at 7, actually, what's 44 minus 8? I might have messed this up. 4 times 3 minus
isn't it 36?
40. It is 36, right? Yeah. So that means
the y is 36, right?
Yeah, a is 36 for sure. So we know at 7, the third function is 36. Yeah, at 7. What about the second function at 7? It is 34. Yeah. 5 times 7 at 7.
Oh yeah.
It's 34. So it is not continuous at 7. At x equals to 7, it is not continuous. Okay.
Because it has to equal 36, right?
Yes. Now we're not done yet. See, now there's 1 and 1 here. So we also have to check it at 1 for the first equation and for the bottom equation.
What do you mean by check by 1? What does that mean?
See, this function is valid up until 1 or close to 1.
Oh, and this one.
Yeah. So we have to check at 1 for both of these. Okay. On to the top one. 12 over 1 plus 3. 12 over 4. That's a 3 on the y value there. Yeah.
Okay.
For the bottom one, 5 times 1 minus 2. That's also a 3. So it is continuous at x equals 1. Okay.
Oh, I see what I did. So there's 7 and the 1. Okay.
Yeah. So their y values there are the same, but here the y values were 34 and 36. It's different. So it's not continuous at x equals 7, but at x equals 1, the y values are the same. So it is continuous. Good.
Yeah. I don't remember if I saw this question yesterday. I think I got it wrong. That would make sense.
Yeah, but we're not quite done yet because this is a trick question. You see, look at the first one. There's an asymptote for the first one.
Right.
It's a reciprocal function. Where's the asymptote?
Isn't that? What do you mean? Where's that? I don't know.
This equation, yeah, this equation. What value of x will give you a 0 in the denominator? Because you can't have a 0.
Oh, -3.
-3. So the function is also not continuous at -3.
Okay. Do I have to write that? Oh, it says, which value is not continuous.
Yeah, so a graph of this, let me show you what a graph of this would look like. So 12 over x plus 3, so that means there's a asymptote at -3, yeah, like that. When x is -3, there's an asymptote. And this function looks something like this, okay? It's going to look something like this. So reciprocal function, that's shifted 3 units to the left. And it's going to look something like this. And then at 1, when x is 1, the y value is 3, yeah? We did that before?
Yeah.
So the first function is going to leave an open circle at 1, 3. Okay? It's going to look like that. Now the second function is a linear function with a y-intercept of -2. And it's valid from exactly 1 till 7, right? And we know for the second function, when x is 1, y is 3. So you see the void left by the top equation, the middle function is going to fill it up because they both have 1, 3.
Okay.
So this function is going to start at 1, 3, and then at 7, it was 34, right? At 34. So at 7, it's 34. So there's an open circle for that linear function like that. Now there's an open circle because this function is not valid at 7, but this one is, yeah. And we know for that function, the y value is 36.
Yeah.
So there's going to be
So
a
that's
closed circle.
closed one. Okay,
and then
I see.
it's clearly going like that upwards, even though that function looks like that, right? Something like that. But that function is only valid from 7 and up. And there you go. This is the graph of this piecewise function. And you can see, right? You can see the graph tells you where the function is not continuous. At 3, it's not continuous. At 7, it's not continuous.
So we just write at 3 and 7?
Yeah.
-3 and 7, sorry.
Yeah, -3, yeah. Okay.
Oh, okay. That's okay. I did it completely wrong, but now I know how to do it. That's good.
Okay, let's do some, what did you want to do? Sorry, you want to do the absolute stuff, right? This one?
No, I did that. I did all of that actually. That was all pretty easy.
Yeah,
I don't know. Yeah, that was just, she just gave it extra. We had another quiz as well. That's what I'm saying, right? Like I'm confident from math, but I feel like when I go to tests, like, because okay, so you know how on tests is like questions A, like which is like fill in the blanks, like these ones, right?
Yeah.
And then there's questions B, which is like you can see at the end of the page. These are question B, right? But what's gonna be C? Like you know, like how usually it's word problems, right? But like I haven't learned word problems yet, so that's why I'm just confused about.
Yeah, that makes sense.
Like I'm confident with all these stuff, and you know how we just reviewed the parent functions. Now I'm confident like 100%, but I don't understand the C part because it's worth the most marks. I don't know what we're gonna do it on.
I want to do these with you. I'm not sure if you did them. Did you do this?
Determine the inverse. Yeah.
Let's see if you got it right.
You just sub in it for y.
Yeah. So I mean, it's gonna take us 15 seconds, right? So you got x equals 3y plus 4 over 9 minus 2y, yeah. And then what did you do? You multiply both sides by
9.9 negative 2.
You got this, yeah.
And then don't you just add 4? Subtract 4, yeah. Wait a second. 2x 9. What's that? Is that 9x?
Oh yeah, 9x because x is up there. Yeah, 9x minus 2xy. Do you have this step? I'm not sure if you do.
I do. I don't remember what I did for that one. So 9x, and then you just eventually have to factor it to get the x and y.
Yeah, exactly. So you subtract 4 from both sides and add 2xy on both sides like that.
Yeah, and then you just factor it to get rid of the x. Isolate the x.
You factor the y, right? Because we're looking for the y, not the x.
Well, yeah. So you need to isolate the y and the x. Right,
so y is gonna be 9x minus 4 over 3 plus 2x, and that's the answer, y inverse.
Yeah, that's I don't know. I don't like this question, but it's just sub and then you isolate for y and x.
What about this one?
Okay. So you just sub in x and y.
No, this is yeah, actually it is. You just sub in x and y. You're right. So x equals minus 4, y plus 6 minus 7.
So you add 7, so it becomes x plus 7 divided by 4, -4, and then square root it.
Square it,
and
right?
then
Square it.
Yeah, square it. I just say square root to everything now, and then you subtract 6.
Yeah, that's right. Yeah. What about this one? This one looks.
You find the mapping and you sub it in. So it'll be x plus x over 2. So that's the mapping rule, right? X over 2.
Yeah. X over 2 plus 5. Yeah, exactly.
Yeah. And then -3y plus 11. And for the x, you'll have 2 ones because you already have 2, right? So you just sub in the -4 for the mapping rule for x, and then the 11, and you get 2 answers. And for the y, you just sub in. So it becomes -3 times 2 plus 11.
Yeah, that's right. That's right. So that's good, man. You're pretty confident with that thing. I don't want to do like a graph of question like precisely.
Yeah, I feel like I need actually I might have a graph question. Just give me a second. I feel like that's what I need to work on. The other thing I'm missing is just the graphing. Because okay, let's say like when it says what's it called, graph a function.
Mhm.
Can we just do that?
Where's the test?
It's not a test. It's just an example he brought up. I'll give it to you.
All right.
So it's an example from a test he previously gave a couple of years ago.
All right. Yeah, let's do that.
Give me a second. I need to open his website.
You have some other courses as well, right? What else are you taking? Because 3 is not.
I had international business. Just walked in, saw the teacher, dropped the course.
Okay, so you only have 3 courses right now.
Yes. Yeah. It was gonna be a waste of time. He wants me to do like a presentation, like 20-minute presentation every week. And I have chemistry, right? So I'm like, how's that? Because presentation actually take a while, to
Yeah.
what's it called? Prepare for, I guess. I'm not bad at presentation. It's not like I don't like them. For the first day, this guy, he gave us a map of the world. He's like, name every country in the world and then like do something related to business. Okay.
Wow.
Yeah, so it's like here. There's just I can download it, but it's just about subscribable. So let's just say.
Yeah, share your screen. Just share your screen.
Oh yeah, right. That's the thing. Okay, share your screen. Wait, host disabled.
Try again.
Is that working?
Yeah.
Okay, it's this one. No, wait. 1 second. Oh, so we did this. Okay, can we do something similar to this actually?
This is not gonna be on the test because this is, or actually, is it? Yeah, this
No,
is the
it is.
polynomial unit. Oh.
That's the questions he had previously put on the previous test. So sketch that function and that one.
Oh no, we haven't done anything like that.
I mean, he covered it in class like slightly. Like he literally covered it on Friday. That last. So I'm assuming he's gonna cover it more.
All right.
I'm not worried about that because you know how it says the 9th degree, isn't it the same? Just even. Yeah.
I
Okay.
mean, you can stop your share. Yeah, I got you.
Okay.
I can just share mine actually.
Stop share.
Okay. Yeah. So that's not from chapter 1, but whatever.
Yeah, these are the 2 questions I just need just to review because he just showed it to us at class, solved it quickly, and it was on a Friday. You know what I mean? So.
Yeah. So like this, right? Like this.
Something like that. Sketch that. Yeah.
So it's something like this right now. So step 1, you need to find what's the degree of this function.
I have no idea how to do that. Like,
oh, so just pull out all the x's. This one has 2 x's, so that's x squared. This one has 1 x, yeah. And this one also has 1 x. Okay.
So does that mean it's even? Like.
So it's x times x times x. It's x4. Okay. Yeah, it is even. Okay. Step 1, find that. Step 2, is it opening up or down?
Down.
Down, right? So it's gonna open like that. I don't know if you've done this unit. Like it's gonna look like this.
I mean, he just showed an example, and he's like, "Do you guys want this on the test?" And then no one responded, so I'm assuming he's gonna put it on the test.
He's
like, yeah, he's like, if this is a complicated question, I'm not gonna put it on the test. Whole class just silent. And he's like, okay, I guess I'll put it. Give easy points for you guys.
All right, it's not that bad. All right, let me guide you. Step 1, identify the power. It's an even power, yeah. And it's a minus on the outside, means it's gonna go upside down. Okay, so you see it's a degree 4, yeah.
Yeah.
So it's gonna have 3 turning points. Okay. And these will give you the x-intercepts. So there's an x-intercept. You always flip the signs inside. So there's an x-intercept at -2. Yeah.
Wait, sorry. Just go back a bit. So you say it's 3 turning points. Is it because there's like 3 like x?
No. It's because it's
or is it always -1?
So the number of turning, but yeah, it's always -1. Number of turning points is technically it's up to. It's up to, like the quantum numbers is up to n-1.
Oh yeah.
It's like the L value, just like the L. L is the turning point. Think of it that way. It's up to n-1.
So it's okay, from 0 to n-1.
Yes.
Okay.
Well, this one has to have 1, right? Because it's gonna go like that. So to come back, it has to have at least 1. So, and again, so that's the number of turning points. It's gonna have up to 3. Okay, 3 turning points. Step 1 done. Yeah. Step 2, we know this is degree 4 opening downwards. So it's gonna look like this, a rough sketch. It's gonna look like an M.
Right.
So if it was degree 3, this is x cubed. It's gonna look like that. Okay. So we don't care about degree 3 for this question. We'll do that later. So here, once you've deciphered that, find the x-intercepts. You see x plus 2? That means there's an x-intercept at -2. Flip the sign. X -1.
Oh, so it comes x plus 1.
Yeah, so the intercept is at 1, +1.
For the square, would it be x plus 3?
Yeah, it'll still be, there's an,
Well, x plus 9. Yeah, sorry.
no,
X squared
There's-
plus 9.
there's still, no, it's not gonna be x squared plus, it's gonna be x squared minus 6x plus 9 if you open it, but you don't have to open it. The trick is, all right, you just look at the number inside. -3, so there's gonna be a turning point at +3, okay? Sorry, there's gonna be an x-intercept at +3, but do you see the squared?
Mhm.
Yeah, see, these don't have the squares. So whenever you have a squared, that means there's gonna be a turning point there.
We have 3 in total, right?
Yeah, you have 3 x-intercepts in total, 3 turning points in total, and at 3, there's a turning point. So we know our graph is supposed to look something like this, yeah?
Okay.
Because it's a degree 4 and it's opening upwards. So now I'm just gonna join the dots. It's gonna look like that, okay?
Mhm.
Gonna come through this, and it's gonna, yeah, you see the squared means at 3, the graph turns. It's gonna touch it and turn back, and there we go. That's the sketch.
Does it always look like an M?
If it's degree 4 and opening upside, yes. If it's
What if-
degree 4, if it was positive, then it's gonna look like a W. Like
Okay.
that.
What if it's okay? And if there's no x squared, it just keep going up, right?
Yeah. So let's do another one, okay? Let's do another one.
Okay.
Let's try and come up with the equation for this one.
Okay.
So first of all, how many turning points are there?
There is 1, 2, 3.
So there's 3 turning points. So this is x to the power of 4.
X to the power 4. Okay.
Yeah.
And if there's 2, it's x to the power 3.
Yeah. If it's 2 turning points, it's x to the power 3, like this. You see this?
Oh, this is the opposite, right? Okay. I see.
Yeah, this is x power 3.
Okay.
This is positive x power 3. Negative x power 3 is the same thing reflected on the x-axis.
It's a M instead of a W.
For degree 4, yes. Okay, notice x power 3 is not a W or an M. It's like a
Well,
snake.
XW3? Oh, I see.
Power 3 is not an M or a W. Power 4 is WM. Power 3 doesn't really have a letter. It looks like a
Okay.
snake.
Can you show me what x to squared is?
Well, x squared, you know, it's a U. Quadratic, right? X squared is
Oh, okay, right. Okay, come on.
x3 is this, okay? X3 is like that. Positive x3, negative x3 is like that.
Okay.
And negative x4 is like this. So this one is a positive x4. W is a positive x4, okay?
Okay.
So once we have that, where are the x-intercepts? -2 and +3, right?
Yeah.
So again, look at this. How do you write this? X plus 2, because that's how you get a -2 there.
Oh yeah, and x plus 3.
Yeah, x
minus
minus
3, minus 3.
minus
Yeah,
3, yeah.
opposite.
See, there's a turning point at both of them, yeah?
There is, yes.
So that they're both squared like that.
Okay, and then there's a third one, no?
So we have x squared times x squared is x4. We're done. What we could do is we could also find the a value that's at the front. There's usually going to be an a value. And we know for this, the vertical stretch factor, we know it's going to be positive because it's opening upwards.
Can we just sub in 2 and 4?
Yeah, exactly. We're going to sub in 4 as y, and we're going to sub in 2 as x. Like that. That's just -1 squared, 1. This is 16a equals 4. So a is 4 over 16 or 1 over 4. And there we go.
That's not that bad. That's not.
You know, we don't have that long. Let me just speed run you through some problems, okay?
Okay. I'm hoping. I think we're gonna cover it. I don't think it's gonna just put in the test like that. We'll actually cover you in class.
So this is a question that we just did. Literally, it's a positive x4.
Just literally the same, but different numbers. Yeah.
Yeah. So if you want to find the a value, you can just plug in like a point, right? Like this point you can plug in. So it's gonna be f of x equals a times x plus 1 squared, because there's a turning point at this x-intercept. Yeah.
And x minus 3 squared.
Oh yeah, exactly. X minus 3 squared, 1 and done. Okay. And to find the a value, just plug in a point.
1, 2, and 20.
Yeah, we wouldn't have to do that. Let's move on. Let's do b.
Okay.
So what's the degree of this function?
X to the power 3.
Yeah, good. And we know the a value is going to be negative. Okay, if it was positive, it looks like this.
So it's going down.
Yeah, exactly.
Yes.
So we can just set it up. So f of x is equals to what?
F of x equals to x minus 3. Well, okay, well, x plus 1
Mm-hmm.
and x minus 3.
X minus 3, but you're missing. We only have power 2 right now.
Oh, squared.
Yeah, good. Because turning point means squared. Okay, that's called order of 2. You know, this factor has an order of 2.
Oh, because it goes down to
Yeah.
10 points. Okay.
And to find the a value, don't plug these points in because you're just going to get 0 equals 0. You can't plug the x-intercepts in. Okay, to find the a value, you can plug
okay.
something else in. Like you can plug the y-intercept or like this point,
I think
anything
they're gonna give
else.
us a turn. I think they're gonna give us 1 point because
Oh, you did. They see this right there, 4 comma negative 10.
oh yeah, you can see that.
Or
Right.
just look at the graph. Yeah, just look at the graph. Let's look at C. What's the degree of this function?
Like x3 or what? Is that
Yeah,
what
yeah, cubic.
yeah,
x3,
cubic,
x3.
yeah.
So y equals, again, to find the a value, you can plug in anything else. Not concerned with the a value. What's the equation?
Can you plug in 5 and 3?
For the a value?
No, never mind. No, me.
It does not pass through 5 and 3.
Yeah. -2 and -10.
Oh yeah, exactly. You can use that to find the a value. Yeah. What is the equation for this?
It is x plus 1
Yeah, good. X plus 1. You're missing something with the x plus 1.
squared,
Yeah.
and then x minus 3.
Yeah, perfect. One and done. Easy. The last one is very similar as well.
But this is going up though, right?
Yeah, this is a positive quartic, positive
Right.
degree 4. Okay. So what would be the equation for this? It's gonna be a times something. A times what?
X plus 1.
Oh yeah.
X minus 3.
Yeah.
And then x minus 5.
Okay, we only have x
Squared.
cubed. 5 is not square. There's no.
No, it's not. It's x3. No, wait, 1 sec. It's first one.
First one is not a turning point either. It's just passing through it. You're missing x minus 0. See right there? X-intercept.
Okay.
So it goes through the, or you don't have to write x minus 0. You can just write x times x.
Okay.
And see, now we have degree 4, yeah?
Oh, I see. I was confused. Now then what's the turning point?
Yeah, we can plug in any value like here or whatever to find the a value.
Okay.
Oh, this one we haven't done yet. You'll know what I mean. Why don't you try this? Open the annotate and try this.
Open the what, sorry? Oh, okay.
Yeah. Try
Yeah.
sketching this. So it's a degree 5. It's called quintic.
So do I show it inside the bracket? Would be just like.
So where are the x-intercepts? Where are the x-intercepts?
X minus 6.
So at 6, there's an x-intercept, right? 1, 2, 3.
Plus 6.
5, 6, right there. There's an x-intercept. Where else?
There's an x.
Yeah, there's an x. There's a turning
So
point.
0.
X.
0.
Yeah, right there. So those are your 2 zeros. Positive 5 looks like positive 3, just more turning points. Okay.
Okay.
So positive 5 looks like that, something like that.
Wait, where does the 5 come from? Oh, right.
2 and 3. The degree is 5. Yeah, the degree is 5. So how do we join the dots? Look at this. At x, when x is 0, there's a turning point, right?
Yeah, and then.
So we're gonna start here because a positive x5 starts where positive x3 starts, or where y equals x starts. Okay, y equals x, x3, x5, all of them start the same place and the same place. So we're gonna start here and there, and at x squared there's a turning point. So boom, like that, yeah.
And then it goes up.
But there's something else. There's a trick to this as well. See, there's a cube here.
3. Yeah.
So when there's a power 3, it's called a point of inflection. Okay, so right there, it's gonna look like a mini cubic function, like that.
So it'll have 2 turning points. It'll go like that, and then.
Oh no, neither of those are turning points. It's like it's like this.
It always looks like this.
Yeah. So when there's a power 3, it's gonna pass through that point like that. Neither of them are turning points. Turning points, you would do a complete U-turn. Okay, like there's a turning point, but that is not a turning point. There's no turning point at power 3.
Makes sense.
Okay, here let's do. Let's say you have x3, x minus 2, 3, x plus 3, 3. Okay, this is a 9th degree polynomial. Doesn't matter what it is. We know the zeros are at 0, positive 2, right?
-3.
Yeah, -3.
Oh, you just do what you just drew.
Yeah, so see, all of them are cubic. So that means there's gonna be again, 9th degree starts there, ends there, just like y equals x. Positive 9th anyways. So there's gonna be points of inflection. So it's gonna go like that, yeah? And it's gonna go like this, okay? Like that. And then again, down there, it's gonna go like this, and it's gonna go like that.
Then same thing for the 2.
Yeah, it's gonna go like that. It's gonna go like that. There's not a turning point, but like this, you know, like this. Or
That's,
like this.
So
These are, yeah.
if I ask you on the, you see how like in the thing I shared my screen, there's like a table with,
Yeah.
and it says turning points, there's just none.
Turning points is for this one up to 8. Because n is 9, right? Degree 9.
Okay, so okay, up to
Up to 8
okay.
turning points, and then is 9 zeros, up to 9 zeros.
Okay, makes sense.
But this one only has 3 zeros though. Well, there are 3, but all of them are repeated 3 times, you know, like 0, 0, 0. If you were to use the formulas, you'll get x is 0, 0, 0, which just means that it's a repeated root. There's 3 unique roots, yeah, but there's 9 in total.
Makes sense.
All right. Yeah, I think that's it for this one. You should be fine for the test.
Yeah, I'm pretty confident on math. Physics, I don't know, man. It just haunts me. I don't know why. I don't know what my problem is physics. Like it's weird, right? I want to go into engineering, but like physics, I'm not like good. Does that make sense?
Yeah, you're not
okay.
gonna have a very fun time, but I guess it's okay. You'll get there.
No,
You'll get there.
yeah, I mean, like for uni, I only have one option. Not gonna lie to you, just civil engineering, just straight up. That's it.
Okay.
Yeah. So I don't know. I'm just worried about physics. Other than that, should be fine.
I'm sure you will be, man.